All right, everybody, we just got it okay to start our planetarium show. So I'm going to put away our space trivia questions, folks, because now we're going to be heading into the unknown. And welcome everybody to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter, and I'm very excited to have y'all here today because you're my favorite place in this entire universe, which is this really cool planetarium dome. And the reason why is because everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors heading throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow. And folks, I'm happy to announce that the show that we're going to be watching right now is hands down my favorite. This show is completely live and different from all the other ones that we've done here in the planetarium today. This one's called Tour of the Universe, and you're going to be hearing my voice for the next 30 minutes. And what this show is about, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things, so just a forewarning. And before we get started with the show, I do have to go over some quick house rules just so that we're all on the same page and have a great time in here. There's a lot of us in here. First off, there's no food or drinks allowed in. If you brought any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We really do appreciate your help. Also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light or loud sound, now's a good time to put those devices away for the next 30 minutes, as these could be very distracting and takes away from the planetarium show experience. And folks, if you need to leave early during our show, our exits will always be at the very top of the planetarium, so always make your way up the stairs to exit. And the staircase can be very steep for some folks. If the staircase is too steep for you, do not worry, just remain seated. Once the show's over, we'll have a staff member escort you to a lower exit when the show finishes, so just stay seated for a bit longer. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to help ground yourself. All you have to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling all the way to the edge of the observable universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite you to sit back, relax, and let's begin our tour of the universe. All right, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, not exactly right on the ground. We're starting off at this really amazing feat, this really cool spacecraft right in front of us called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I always hear about it in the news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility. It's a laboratory that orbits all around our planet Earth. And they conduct many different types of science experiments up here, much further away from the ground with less gravitational influence. And some of the different experiments they'll conduct up here are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? Which way do the roots grow? Another one that they've tried out is what happens when you try to spark a match in space. Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down your muscles as much. So if you plan to live in space for a long period of time, remember to exercise daily. And the space station looks really big here in our planetarium dome, but it's not that big. In actuality, it's only about the size of an American football field. If you've never been to an American football game, that's okay. You can also use the entire California Academy of Sciences, the museum we're sitting in. That's about how big it is. And also what's really impressive, folks, is that this thing is going incredibly fast. It's traveling at a whopping 17,000 miles per hour. where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. Got him. Anyways, also, folks, this looks really far away from our planet, but it's not too far either. It's only about 225 miles above the surface of our world. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip with the family to get away for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans out into space nowadays, only 225 miles above the surface of our world. The reason why, well, it's very expensive to travel into space. You got to build yourself a rocket ship, buy yourself one, or hitch a ride, and then you get to buy so much rocket fuel. And once you get all that rocket fuel to escape the Earth, then you have to account for all the food, water, all the air you're going to be breathing while you're up here in space, so the bill is quite costly. But now, folks, we're going to see the International Space Station slowly fade away down to the city lights down below. And before we lose track of it, I'm going to add a nice little orbital path so we can see it as it slowly fades away. And now, folks, we're able to see our entire planet all the way out here. And I want to let you know that the space program that I'm using here in the planetarium is something that you can go home and download if you want to fly through space, just like how I'm doing. The space program that we're using is called OpenSpace. So if you go to OpenSpace Project, type that into your favorite search engine, you can find the link to download this, and you can fly through space. But just to let you know, this is uses a whole lot of processing power. So if you have it uses a lot of data and information, so if you have an older computer, it may slow down your computer, may not even be able to run it. But if you got something new or a gaming computer, give it a try, it's a whole lot of fun. But if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you don't have to download anything, and you can fly through space, and it's so much fun. But in here in the planetarium, we're using OpenSpace. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science up here, and of course they had some fun. They got to play some golf. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we need to figure out how we're going to be living out here in space. And the moon is the perfect stepping stone how we will be figuring that out. And what's really amazing is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there, and that's going to be very helpful because we can pass electricity through it, we can melt that ice, and we can separate the hydrogen and the oxygen, and both that stuff's very valuable when you're really far away from home. So again, we humans should be heading back to the moon in the next few years. Look out for any news about Artemis. And folks, when you look up at the moon here from planet Earth, sometimes it feels incredibly close. It feels like you can reach out your arms and touch it. But the moon is incredibly far away. It's about 240,000 miles away from our planet Earth. Whew! 240,000 miles? Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say, bye-bye, moon. Oh, so cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away, just like how we saw with the International Space Station. And just like before, I'm going to add some planet trails so we can keep track of all this stuff while we're out here in space, because again, space is really big. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view, so here comes the sun. Do-do-do-do-do. And also, folks, the sun is incredibly far away from us as well. It's about 93 million miles away from our planet. Whew, 93 million miles, that is a good distance away. And again, we're the third rock from the sun, so we have 1, 2, 3, that's us on the third line. 93 million miles between us and the sun. Now, in terms of speed of light, that's not too far away. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. Not too bad. And this is a good concept to keep in mind, folks, because let's say let's say the sun was to turn off all of a sudden, there was no more sunlight being emitted from the sun. Well, that last bit of sunlight will travel that 93 million miles at 8.5 minutes at the speed of light, and then all of a sudden, the daytime on Earth would become nighttime. And again, this is such a great concept to keep in mind because this works for really far away objects in space as well. Let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago in the past because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense, which is really cool. But now that we got a nice bird's eye view of our solar system, I'm going to do a quick refresher of what we have in our solar system. Right in the middle is our star, the sun. Closest planet to the sun, we have Mercury. Then next we have Venus, and then we have Earth. That's us right over there. And then past Earth, we have Mars, the red planet. And past Mars, we have something called the main asteroid belt. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. There's roughly about 1 million asteroids in this region. And then past the asteroid belt, you have the really big planets, the gas giants, the Jovians. You have Jupiter, the largest of them all. Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and of course, Neptune. And we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen, just right above. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And I know a few of you are probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah. Pretty much in 2006, we found more than 400 objects out here because our telescopes and technology greatly improved. So we're able to see much smaller objects much further away. And some of those objects that we discovered in 2006 were bigger than Pluto. So we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be to consider it a planet. And folks, all the scientists and astronomers that day came up with 3 different criterias, and that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And that's the really cool thing about science, because as we learn new things and our technology improves, science is constantly updating and changing, so I really love that about science. And also, the Kuiper Belt is like a second asteroid belt way out here past the orbit of Neptune. What you're mostly going to find out here are icy asteroids and short-period comets that don't stray too far away from the sun, so very similar to the main asteroid belt, just icy. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures has yet to reach travel as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours to get all the way out here. Not too bad. But now, folks, it's time for us to leave our planetary scale behind us, because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri just crossed our view on the left-hand side of our screen. So we're right in the middle of our screen right here. That's our solar system. Alpha Centauri on the left side, that star moving closest to us. And again, 4 years at the speed of light just to reach the next star system, folks. Well, that doesn't put into perspective how long it would take us humans to travel there. Folks, if you got in a rocket ship today of today's capabilities, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that journey. Whew. And that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. And folks, we have not stepped into the 80s. We are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later, the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before the early 1930s, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us. 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you looked at the very top of our screen right there, you can see that we pointed a telescope in that one spot for about 10 years, and we found a whole heap of exoplanets. So the more we scan, the more we'll be finding exoplanets, and that 5,000 number will be increasing. Not to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed, created right now, so we've got a few years before those are launched into space and we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light-year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, the planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as our radiosphere is always growing, but it becomes weaker as it does. But folks, I'm going to be putting away the exoplanet markers, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So keep your eyes on that radiosphere as we continue to zoom on out. Alrighty, right, folks. We are now looking down on our Milky Way galaxy, the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light just to cross it once. And our Milky Way galaxy is incredibly large. It's so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I want to show you what it looks like from the side. You're going to notice that our Milky Way is very flat. Kind of looks like a big pancake or a frisbee in space. And this is important, folks, because when scientists and astronomers want to learn about the universe, it's much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture continues to expand, folks, you're now going to realize that galaxies are not distributed out evenly throughout space. There's not one galaxy in a nice little line and another galaxy here. Instead, galaxies like to clump together in large groups and clusters, or they create voids where there's very few galaxies or no galaxies at all. So we could see some nice galaxy clustering towards the center of our screen. We could see very few galaxies on the very top left of our planetarium dome. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who compiled this amazing representation thanks to the work of other astronomers working beside him over decades of time. So big shout out to Dr. Brent Tully. I love flying through this map. But now, folks, we have automated systems that are mapping the most distant galaxies. So now we're going to be seeing the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And by the way, as we start to swing around, you're going to realize that the large-scale structure of the universe is not in the shape of a bow tie or a butterfly as we start to swing around. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way galaxy? If we were to line up our Milky Way, it would line up right down the middle, up and down, just like so. And again, we like to point our telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which of course blocks our view of the universe. But astronomers still wanted to make sure that there was galaxies through the plane, so you have this purple survey of galaxies. You'll notice that we're still able to find them, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill out all these areas that haven't been filled in yet. So it's just a matter of time. And speaking of time, we're running out of time, so we got to continue on with our show. 30 minutes is just not enough time. So let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. And quasars are going to be represented by nice orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years apart. And so now, folks, we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's look back further before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we are looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, what we're looking at is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to a large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of light years in time. But now that we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back home, towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And now, folks, let us return back home towards planet Earth. All right, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, folks, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're making our way back into our Milky Way galaxy, folks, back into that radiosphere. And now we're going to be making our way back to our solar system, our star system, our little neighborhood in the vastness of space. And as we approach our solar system, we're now going to be passing those spacecrafts we sent out in the 1970s to explore the solar system, passing the Kuiper Belt and the orbit of Pluto, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, if you want to share this show to a friend or family member who was unable to make it today, you can check out this exact show on the Morrison Planetarium Facebook page or the Morrison Planetarium or the California Academy of Sciences YouTube page as well. So feel free to share this show out with friends and family who are unable to make it. But hey, look at that. We made it back home safe and sound just in time for dinner time, folks. And that's all the time we have for today. So make sure to get home safe, and we'll see you next time. Thanks for stopping by, everybody.